Okay, so we're gonna do this assignment, the new assignment, based on the concept of chi-square, and the symbol we use is like this. And there are three types: goodness of fit, there is the homogeneous, and there is the independence. Now this assignment covers all three, not all three, but it's for the entire chapter. For the midterm, you're only going to see the goodness of fit and maybe a short answer. That's what he mentioned, a short answer for the other two. Now the first question in the assignment, they told you you have a town and they want to test the ethnicities of the people living in this town. They believe that it's equally likely to have people that are Caucasian, Mexican American, African American, and Taiwanese American. And when they say they think it's equally likely, they mean since there are four, 25% of the town are Caucasian, 25%, 25%, 25%, they're equally likely. And then if there were two, it would be 50-50. If there were three, it would be 33, 33, 33. That's when they say equally likely. Not necessarily equally likely in all the goodness of fit ideas. Sometimes they might ask you, you have a town, and people living are one of the four groups, but they believe that the Caucasian represent 70%, the Mexican represent 20%, the African represent 7%, and the Thai represent 3%. So they could give you in the goodness of fit the four groups with certain percentages. In this question, they tell you equally likely, so you could assume 25, 25, 25. Okay. So I'm going to erase this to continue the question. The first thing here, they wanted you to test for assumptions. What are the assumptions for this chapter? Now, this chapter has three types of assumptions. The first assumption is called counted data condition. You need to make sure that it's a categorical variable, and you need to make sure that these numbers represent counts. If you look at the Minitab provided, in the Minitab you see something like category 1, 2, 3, 4, and then you say the word observed 3, 4, 7, 6, 3, 2, 3, 4, 3080, 3652. You got percentage, and that's what we say, 25, 25, 25, 25. You also got the expected number, and the expected number was 336.5, And that's for all of them. And I'll talk about this table later on. The table also told you that the degree of freedom is 3, the chi number is 57, and the p-value is 0. Okay. First of all, when they did this study, okay, I'll tell you the story. When they did this study, they believed that the 4 ethnicities, they're equally likely to have them, so 25% each. So that's what they believed. So they went to the down, they took a sample of 13,442 people. Again, this is what they believed. So they took this sample and they asked people to identify themselves. 3,476 identified themselves as Caucasian. 3,234 identified themselves, I believe, like African, not Mexican. This group, 3,080, identified themselves as Mexican, and 3,652 as Thai. These are the percentages from doing the study. And this is what they believe. What you're trying to see, do they go together? Does this show that they're equally likely? You see that the numbers are a little bit different, not exactly the same, but is the difference between this and the fact that they're supposed to be 25%, is it a big difference or statistically not a big difference? So the counted data is met. Reason, we have one categorical variable, in this case the ethnicities, and observed numbers these numbers are counts of people. So these numbers are not dollar value, they're not inches, they're not meters. These numbers are counts of heads, counts of people. So the first condition is met. We have one categorical variable, the ethnicities, and the observed numbers are actually counts of people. So the first condition is satisfied. Condition number 2 is the independence assumption. And this is pretty much the same as the previous chapters. This sample must be selected randomly, and it's mentioned in the question, so you go met sample of 13,442 was selected randomly. So groups are independent of each other. Good. So counted data met, the independence assumption met. One more assumption. And the assumption here is sample size assumption. Also called expected cell frequency. Now, is the sample large enough? Now, what they did was looking at the expected number. And in this case, you have the same expected number for all four, 3,360.5, Is this number more than 5? Then yes, condition met. So condition met, minimum, all expected values are greater than 5, since minimum, the expected value 3360.5. So yeah, all conditions in this case are satisfied. Okay. The next thing was to state the hypothesis. So how do you state the hypothesis when it's goodness of fit? You start with your categorical variable, and we know it's ethnicities. So you put the name of the categorical variable. Name of the category is the same across the three, or in this case, the 4 groups of ethnicities for all people in the population of this town. So I'll underline the thing that could change, the number of groups, and yeah, I mean, it's very straightforward. All people, or all, yeah, it's usually people living in this town, because they talk about a certain town. So this is H0. You say they're the same. HA, you say exact same thing, same order, but instead of same, you say not the same. So it's same, not same. Okay. I guess I can delete some of this. Okay, so after doing this, they wanted to see what the test value is, what the chi-test, and so the chi-test, you go to the mini tab, you see the chi-test is 574304, and the p-value is 000. And then they want you to make but before we make a conclusion, how do they get the degree freedom of 3? Because the way you do it in goodness of fit is different than the other two. The other two is the same concept, pretty much. First one is different. Degree of freedom would be how many different groups you have minus 1. There are 4 ethnicities, so 4 minus 1, 3. That's how they got the 3. But again, homogeneous independence are a little bit different. Now, conclusion. Assumptions met, so we start with since assumptions are satisfied, or since assumptions hold. Remember, when we do the conclusion here, we don't have alpha. So, since we don't have alpha, we have to state the conclusion in terms of strengths. Your p-value is 0, 0, 0, 0. So, you go to that strength graph or table that I sent you, you see that this is actually less than 1%, and in this case you have strong evidence to support HA. So you say p-value is less than 1%. We have very strong evidence for HA. But instead of HA, you say what HA is. So we have strong evidence that ethnicities is not the same. So we have enough evidence that the ethnicity is not the same across the 4 groups in the population. So you say what that is, it works. So you repeat HA. Okay. Now this is so we proved that these numbers don't. I want to talk about this a little bit because I know that he, in the exam, will ask you for some calculation. So I'll talk about it briefly. So again, for the category, there are 4 different groups. You're always going to be given the observed. So they did a study, they asked 13,000 plus people. In fact, the total number of people they asked, 13,442. So they found 3,476 belonging to this group, 3,234 belonging to the second group, and this belonging to the 4th group. They think that it's equally likely to have the 4 groups. So percentage in this case is 25, 25, 25, 25. Now, the expected number in this case is given. Well, if it's not given, this is what you do. For the expected, you take this percentage times the number. So we take 25 times 13,442. It's like, in this case, it's the same number, but it's not necessarily always the same number, but it's 25 times this, and that's how they got the 3,360.5. Just wanted to have my calculator. Now, I want to show you how they got this number. So, what if you're asked to calculate the chi number? That's 574304. To do this, we're going to add a column called the chi column. So what we're going to do is, for the chi, for each one of them, we're going to go observed minus expected squared over expected. So I'm going to take the difference between the observed, so brackets, 3,476 minus 3,360.5. You square this and you divide by the expected. That gives you the first one. I'll stick to 4 decimal places, 9,697. You do it for this one. Brackets, difference squared over expected. So brackets, 3,234, 3,360.5. You square this, 3,360.5. And this one is 4,7619. You do the same. Brackets, difference between 3,080 and 336.5. You square over 3360.5. This number is 234133. You do the same. Brackets, difference between 3652, 3360.5, you square 3360.5, and this number is 252856. After you do the individual chi, if you add them all, 3.9697 plus 4.7619 plus 234133 plus 252856. You add them all, it gives you 574305 or 4. This is how it's done. This is how they calculate the expected value, the chi-square. So the expected value is whatever the percentage here times the actual sample. This one, you take the difference squared over expected, you add them all up, that's your chi. So that's the first question in your assignment number 4, I believe. Okay, question number 2. They tell you in the beginning of the question that they took samples of people or students, some with bachelor's, some with master's, some with PhD. They sent them surveys. Some of them returned it. Some of them did not return them. They give you this table too. So they tell you, for example, 72 of the bachelor people returned, 28 didn't. Here, 44 returned, 6 didn't. Here, 18, 7 didn't. And the first question asked, is this homogeneous, or they also give the Minitab. I'm not going to put the entire Minitab. You'll see that the Minitab, they give you the same categories. And then you have a returned not. So I'm only going to give you this section to talk about it later. Here you have 28, 23, 43, 8920, and here you have the total. There are 41 shouldn't say 41. Yeah, 41 would be the not, yeah, 41. And you have the total here of 100. And then you have the grand total of everybody. But you have the complete table. I'm not going to talk about it. And you also have 2 lines, one called likelihood, the chi, and one called Pearson. You're only concerned with the Pearson. Why they give you both, I don't know. We only care about the Pearson. So Pearson chi-square 5.096, degree of freedom is 2, and the p-value is 0.78, and the alpha given in the question was 5%. Okay, the first thing, now when you have the structure of Minitab this way, you have under each category 3 numbers, 3 numbers, 3 numbers, 3 numbers. I only give you this section for bachelor and nut, but there are 3, 3, 3 everywhere. When you're given this, given table like this, that means that it's either homogeneous or independent. Now, how do you tell whether it's homogeneous or independent? Well, it depends on the way they tell you, because sometimes it could be confusing. Now, when they mentioned in the question, was it one sample? Did they say one sample selected? Or did they say samples selected? Was it one sample or samples? You'll see they selected samples. In this case, it's homogeneous. So, you say we have 1, so it's homogeneous, of course. We have 1 categorical variable, in this case, returning survey, and 3 populations, and in this case the bachelor people, masters, and the PhD. Again, when they say you're selecting samples, so that means you have 1 categorical variable, return, not return, and you have, depending on how many samples or populations you're selecting. In this case, you're selecting 3 populations or 3 samples. This is homogeneous. And independent, they could tell you that you have 1 sample selected, and then they divided them into bachelor, master, PhD, and they asked them a question. In this case, you have 1 population, 2 categorical values. I'll talk about this more, and I'll give you an example when I do the midterm review, but for now, homogeneous is 1 categorical variable, multiple populations, because they mention samples. And they also tell you that the conditions here met, so you don't worry about it. They wanted you to turn this into percentage. So to turn this into probability percentage of return, not, and same bachelor, master, PhD. So we stick with the same group, first group, 72, 28, total 100. So there are 100 PhD. 72 of them returned, so 72 out of 100, that's 72%. 28 did not return 28, that would be 28%. 44 masters, 6 not returned, 44 returned, total 50. So the return would be 40 out of 50, that's 88%. And this one, 6 out of 50, and that would be 12%. This group, 18, 7, total 25. So returned 18 out of 25, 72, and 7 out of 25 is 28. This is how you turn them into percentages. And then they tell you, looking at this, without doing any statistical analysis, do you think that the groups are equal or the same? Well, these two are the same. It's the only problem with this. Would you consider this far from these or not necessarily far? Well, there's no good way of looking at this. We prefer to do the analysis first and then answer this. But I can tell you, looking at them, they're not way different. They're the same. When will you consider that the percentages are different? Let's say that this was 60, 40, and that was 88 or 90%. So this is like 1.5 of this. So anytime it's 1.5 or more, you consider this to be different. Otherwise, no, they're very close to each other. But again, you can, if you get this, I don't believe you're gonna get it in the exam, but if you get the question of looking at them, determining if they're different, the same, leave it, do the chi analysis, and then when you come back to it, you can do it later, because the chi analysis would also prove the same thing, whether they're the same or not. So I'm telling you now that they look the same, they're not way different. We will prove this using chi-square analysis. The next thing after this is to assess significance. So since alpha is given, we can assess significance. Well, before this, there's a question asking you what the test is and what the p-value is. I told you you only need the Pearson line, so the chi number is this, and the p-value is this. You'll see the degree freedom is 2. They might ask you in the question how to do or how to find the degree freedom. I told you earlier when I did the goodness of fit, the degree freedom for the goodness of fit is just number, how many categories you have minus 1, the normal way. And I told you for homogeneous independence, degree freedom is done differently. Degree freedom is number of rows minus 1, number of columns minus 1. So we have 2 rows, we have 3 columns. This is 1, this is 2, 1 times 2 is 2. And don't make the mistake, sometimes they give you the table and they tell you what the totals are. So they give you the totals everywhere. And people make the mistake that when they count the rows, they say 3, they count the total. No. Even if they give you the total, we're looking for the actual group. So this is 2, this is 3. We don't count the total. So the test in the Pearson is 5096, p-value 0.78, degree freedom is 2, and this is how it's done. Now, the next thing is they want you to assess significance, because alpha is given. You know the significance, I wrote it down for you in the previous, for the previous assignments. P-value is 7.8, that's more than alpha of 5%. So we have insignificant results. We do not reject H0. We do not conclude HA. So we don't conclude HA in this case. Now, finally, talking about the conclusion, you say, they told us that the assumptions are satisfied. Since assumptions are met or assumptions hold at 5% level of significance, we cannot conclude it. We cannot conclude HA, but we say what HA is. We cannot conclude that returning survey is not the same for the three populations of bachelor and master's and PhD. Now, so what we're saying here, we cannot prove that they're not the same. Watch for the double negative. It's a little bit confusing, but what we're proving that they're the same. To make life easy, anytime you conclude reject H0, that means HA is okay. Anytime you don't reject H0, that means that H0 is okay. So here, we don't conclude HA, we don't reject H0, meaning H0 is okay. And H0 says they're the same. So we proved statistically that they're the same, or we cannot prove that they're not the same, meaning the same thing. We basically prove statistically that the groups are the same. So in the exam, you can go back to that question where they tell you look at the percentages and say, yeah, they're close to each other, they're the same. So this is how to handle the chi-square question. One more thing is they might ask you to do for the homogeneous or the independent. I told you in terms of conclusion and math and everything, these two are the same. In the mini tab, so you have return, not returned. And you got, for example, here, you got 72 and two more numbers. Here you got 44 and two more numbers. Here you got 18 and two more numbers. In this section, I gave you all three numbers. 28 and 23.43 and 8920. Here, this number would be 6 and two more numbers. And this number would be 7 and two more numbers. And also in the mini tab, you'll see that this number is given, the total here, 134. And the total here is given 41. And also the total for each column, for this is 100, for this would be 50, and this would be 25, and the total of everything is 125. That's if you add the three numbers or if you add these two numbers. In the exam, they'll ask you, explain how these are calculated, which is BSC not. How are these three numbers calculated? Well, not all of them, because the structure, the first number you see is called the observed number. And that's the number, if you remember, that was in the table of return not BSc and Masters, PhD, 72, 28, 44, 6, and 18, and 7. So these numbers, all of these numbers, are the observed numbers. So that's what the first number is. The second number is the expected, and the third number is chi. So it always OEX or observed expected chi. So we need to find the expected for BSC and NUT. How would this number calculated? Expected and that's the same for all of them. You can try all of them later and make sure you get it right. Now, to do this, we take total row times total column over total system. For example, we know that we're working here. This is the row, this is the column. What's the total row? 41. What's the total column? 100. What's the total of the grand total of the total of the system? 175. So if you're asked for this one, it's 41 times 50 over 175. If you're asked for the expected, say, this one for PhD, total row 134, total column 25, so 134 times 25 over 175. So it's total row, total column. You can try and calculate some of them to make sure that you end up with the right number. So 41 times 100 over 175, that gives you exactly 234286. That's the exact number. They rounded to 2 decimal places, so it's 2343 if you round it to 2 decimal places. Now, we did the expected. The chi number is similar to the chi number we did for the previous question. It's always O minus E squared over E. So it's always like this. The difference between observed, expected, you square this and you divide by the expected. And if you remember, that's exactly what we did for the goodness of fit, but expected is done a little bit different. So 2343 squared over 2343. This number is 8914, but they rounded to 2 decimal places and they probably use the exact number. If you do it correctly, it would be like with the, I use 43, I'm supposed to use this one. If I use the exact number for 286 and for 286, I'll end up with 8914.